Guys, today we're going to be learning about how to calculate mechanical advantage. But before we do that, I want to talk about what mechanical advantage actually is. So if you are using a machine, you want that to be an advantage to you. If the machine is not helping you, you don't need to be using it. So we want to talk about how we calculate how much work this machine is doing. We found that yesterday when we did force times distance. Now we're going to see the mechanical advantage. And the thing to look for is if you are given distance, you're going to have a different mechanical advantage formula than if you're given force. So the ideal mechanical advantage is that a simple machine would be considered ideal if it had no friction. Okay, but actual mechanical advantage is we know that all machines have friction. They do not have as high of a mechanical advantage as ideal because some of the effort is lost in overcoming friction. So ideal is saying, what if we didn't have friction? And this is saying, okay, well we do, so let's just measure it with force. So for ideal mechanical advantage, we have our effort distance, which is going to go in the top, divided by our resistance distance. I'm going to write ED, divided by RD, resistance distance, and that's mechanical advantage. And our units for distance are going to be in meters. So right here, if we're using force, we're going to be using newtons. So if they give us a newton, we're going to not be putting effort on top. We're going to be putting resistance force on top, effort force on bottom, and that is also our mechanical advantage. So efficiency is how well we do something. So a machine multiplies the effort force. How effective is the machine? How effective the machine is called its efficiency, how effective it is. All right, so let's look at one. If we look at the bottom, it has, the first thing I notice is it's got centimeters, and centimeters is distance, so we are going to use the formula with distance. So I'm going to go ahead and write my formula right here. And I've got effort distance over resistance distance. So I'm going to come down here and work this out. Okay, so let's decide which one our effort distance is and which one our resistance distance is. So this is our resistance. Our effort, we are having to pull it up 25 centimeters. So 25 would go on top, and then 5 is our resistance. That's how much is resisting us. When you're pulling something up, that height right there is what's resisting your motion. So 25 divided by 5 equals the ideal mechanical advantage would equal 5 centimeters. Okay? So let's flip over to the back. Now we notice right here, we're also given distance. Okay? So you would work it out the same way. You would draw your triangle and put your 24, your effort distance, how far you're pulling it up, over the resistance distance of 5 and divide. Now let's go down to the bottom. At the bottom, you can see that we are given force. Now, remember, our formula is different. We got resistance force over effort force. I'm going to draw my triangle. Resistance force goes on top. Effort force goes on bottom. So if I'm looking at this example, my resistance force is 35 newtons. That's how much gravity is pulling down. So I'm going to write 35 in the top. And then 15 is going to go on the bottom. And then if you do 35 divided by 15, you get 2.3 repeating, and that is also in newtons. All right, so what I want you to do is I want you to flip over to the back of this page, and what you'll notice is that they give you a sort of just random questions here about effort force, resistance force, mechanical advantage, and efficiency. Now, efficiency is on the back on our notes page, which was page 25. This is on page 25. This is on page 25. And our effort force is the force we exert. And the resistance is the force resisting our effort. All right, so I want you to use this. You know that if we're doing force, resistance goes on top. Resistance force divided by effort force, and find out the mechanical advantage of the crowbar. And then tell me in your own words, what are two ways machines make work easier? And tell me the difference between ideal mechanical advantage and actual mechanical advantage. All right, the last thing we're going to do is we're going to work out some problems. Just remember that if you are given force, resistance goes on top. If you are given distance, effort goes on top. So right here, we are given force, newtons. So my resistance goes on top. And here, our effort force goes on bottom. And it tells you, you apply 18 newtons. That is your effort. So 18 goes on bottom. Okay? There's a resistance of 9 that goes on top. 9 divided by 18 is 0.5. All right, now this one is in centimeters. So we know if it's distance, effort, distance goes on top, resistance, distance goes on bottom. So you apply a force. The effort length is 26. It tells you 26 goes on top. And it tells you 4 goes on bottom. All right, so just remember, if you are given force, you put resistance on top. If you're given distance, you put effort on top. Now, I don't want you to worry about this one or this one, but I do want you to try it and see if you can figure out how it goes, okay? And that is all that we are doing today. Have a great day.